Have you ever wondered what really goes into keeping people safe in some of the most dangerous jobs out there? I mean, we see the gear, the hard hats, the harnesses, but behind all of that is a detailed life-saving blueprint. Well, today, we're going inside one of those blueprints. We're going to deconstruct a real-world corporate safety document to really understand the science and the strategy behind preventing catastrophic falls. So, let's break it down.
Everything, and I mean everything, starts with this one single number, 1.8 meters. That's just under 6 feet. This one measurement is the trigger for an entire universe of safety protocols, specialized equipment, and life-or-death procedures. So why that number? What makes 1.8 meters the magic number? It's definitely not arbitrary. And answering that question is really the key to understanding how safety professionals think, how they systematically deconstruct risk and build systems to control it.
So here's our game plan for this explainer. We're going to start with that 1.8 meter rule. Then we'll dive into something called the hierarchy of controls. After that, we'll look at how to prevent a fall and then how to survive one if it happens. And finally, we'll see how the entire safety system ties it all together. Okay, let's jump right into that foundational rule. Because as you're about to see, it's not quite as simple as just pulling out a tape measure. The safety standard we're looking at defines it like this. Yeah, you're working at height if you're 1.8 meters up or more, but, and this is so important, you're also considered to be working at height if you're above anything hazardous. We're talking machinery, dangerous chemicals, you name it, even if you're only a foot off the ground. It's not just about how far you can fall, it's about what you could fall into.
And the standard gets even more specific. A risk of a fall isn't just about standing on a high platform. It also means you're just near an unprotected edge or an opening in the floor. Or maybe you're on a surface that could break, or one that's just plain slippery. It's a full 360-degree view of what could possibly go wrong.
Okay, so a risk of a fall has been identified. What happens next? Well, it's not just a case of grabbing a harness and calling it a day. Professionals use a very specific prioritized strategy. It's called the hierarchy of controls. Let's see how it works.
And this right here is the core idea. Not all safety solutions are equal. Not even close. So instead of just grabbing the nearest tool, the standard forces you to think in a really disciplined way. You have to prioritize the most effective solutions over the least effective ones. It's all about engineering safety from the start, not just reacting to danger later.
And here is that system in action. The hierarchy flows from most effective at the top down to the least effective. So what's the absolute best control? Number 1, just do the work on the ground. Simple, right? If you can't, number 2 is to work on a permanent, solid construction. Only then do you move down to temporary prevention devices. And notice what's at the very bottom, what's considered the least effective option, that personal gear, the fall arrest systems. They are the absolute last resort. So let's dig into those top tiers of the hierarchy. The methods that are all about making sure a fall never ever happens in the first place. This is the gold standard. A solid construction isn't just any old floor. It's a fully engineered, permanent solution complete with guardrails, toe boards, and safe ways to get on and off. The goal here is to completely engineer the hazard out of the equation, just eliminate it. This slide shows the difference between the two main types of personal gear perfectly. A fall restraint system is basically like a leash for a person. It's physically too short to even let you get to the edge. It's proactive. A fall arrest system, on the other hand, is a safety net. It does absolutely nothing until you've already fallen, and then, hopefully, it catches you. It's reactive. And the hierarchy always pushes you to choose restraint over arrest. But what happens when prevention just isn't possible? When the only option left is to prepare for the absolute worst-case scenario? Well, that brings us to the very last line of defense.
And the document is crystal clear on this. You only use a fall arrest system when it's just impossible to engineer the risk away with things like guardrails or scaffolding. Using this gear is basically a fundamental admission that a fall could actually happen. Your goal has officially shifted from fall prevention to fall survival.
And that survival system is made up of very specific components. You've got a full body harness to distribute the insane force of the fall. You've got a special lanyard with a shock absorber built right in to reduce that violent jerk. You need special hooks that can't accidentally open. And maybe most importantly of all, you need a rock-solid anchor point. So how solid does that anchor point need to be? This is where the physics get pretty mind-blowing. The standard says it has to withstand 15 kilonewtons of force for just one person. To put that in perspective, that's the equivalent of holding up about 1.5 metric tons.
We're talking about the weight of a small car. That is the staggering, incredible force a single falling body can generate. And that's exactly why this direct quote from the document is so critical. You know, it might seem intuitive to just clip onto a nearby handrail, but the standard makes it explicit. They are absolutely not designed to withstand those immense forces. This one sentence could literally be the difference between a successful rescue and a catastrophic failure.
So we've got the rules and we've got the equipment, but that is not the whole story, not by a long shot. For any of this to actually work, it has to exist within a much larger, comprehensive system.
Here's the crucial point. Safety isn't just about having the right gear. It's a living system with two interconnected parts, the equipment itself and the people who are trained to use it correctly. If any one of those parts fails, the whole system can just collapse. And just to give you an idea of the incredible level of detail we're talking about, check out this table. Every single piece of equipment, from a permanent platform to a temporary scaffold to the harness itself, is governed by a specific, highly detailed engineering standard. Absolutely nothing is left to chance.
This is the process side of the system. Safety is a cycle, right? It's not a one-time event. Equipment is checked when it's brand new. Then it's inspected by the user every single time before it's used. It's regularly maintained by experts, and every one of these actions is documented in a permanent record.
And finally, we come to the most critical component of all, the person. All the standards, all the engineering in the world, it's all useless if the people using the equipment aren't properly trained and proven to be competent. The human element is the ultimate linchpin of the entire system.
So in the end, what is all this for? The document states its purpose pretty plainly. It exists to prevent damage to property, sure, but way more importantly, it exists to prevent injuries and to save lives. That is the fundamental why driving every single rule and every piece of equipment we've talked about today.
So we've just deconstructed the safety blueprint for working at heights in one specific high-risk industry. It really makes you wonder, doesn't it? What other invisible, highly detailed systems, just like this one, are operating all around us, keeping us safe in our everyday lives?